In this problem, we have to maximize the function. We have it equal to x plus y, and it's subject to our constraints. Well, these are our constraints. We have 3 of them, and we are going to start looking at our constraints from easiest to hard. This is our first constraint. We're going to label this 1, and we're using this as the first constraint because it's the easiest. Now we have the second constraint as 2. It's the second easiest, and then we have this third one right here. So we are going to look at all of these, and it's going to become important when we graph them. So we're going to pull out a y-x graph like this, and we can start graphing them. However, we need to write these in simpler equations. So I'm going to color code these. The first one I'm going to do in gray. We're going to solve in terms for y. So we have y is less than or equal to 6 minus x, because we have to bring this x over to the right side. For this one, we have y is less than or equal to 10 minus 2x. And then for the last one, we are just going to have that our x has to be greater than or equal to 0, and our y has to be greater than or equal to 0. So now we're going to solve for this first. We're going to plug in our specific points. We have x, y. We have a negative x on this side and a negative y on this side. Our x has to be greater than or equal to 0. This is 0 right here. This is also 0 right here. And our x is negative on this side of the axis. So this is negative x, and this is negative x. That means we're not going to plug anything in this region, so we can just x out these regions. And we're only going to be looking on the right side of our graph, again, because that is where the positive x lies. Now we're going to look at y is greater than or equal to 0. Well, kind of the same thing. We have our positive y up here, and we have a negative y down below. That means everything in our lower region right here is going to be a negative y, and we want our y to be greater than or equal to 0. So we would x out this quadrant. We would also x out this quadrant. Side note, this top right is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. That only leaves us with the top right quadrant. So we are going to have to solve for in here. This is where our function is going to lay. Now we're going to look at part 2, where we have y has to be less than or equal to 6 minus x. Well, we just need to graph a line and get the idea of it. We don't need to graph a lot of points, just the specific ones. We need to find where we have it touching the axis. Well, where is it touching the axis? It's actually touching the axis at 2 points, when our x is 0 and when our y is 0. So we are going to branch this off. When our x is 0, we're going to have y has to be less than or equal to 6. So our y has to be 6. And our x, again, is 0. So 0x is going to leave us plot something like right here. We'll have 1, 2, 3, 4, 5, 6. And we'll just go 7, 8, 9, 10. Same thing for this. 1, 2, 3, 4, 5, 6, 7. We'll just stop at 7 for here. And now we want to see on the x-axis where it is 0. So we're going to make our y 0 and say that this has to be less than or equal to 6 minus x. Well, our x, if we move this over, is less than or equal to 6. This is going to be our equation. So when our y is 0, our x is 6. We're going to plug this into this point, and now we can draw our line. It's going to look something like this. Now we're going to look at part 3, and we're going to do the exact same thing. We are going to see where our y touches the y-axis and where the x part touches the x-axis. So if we plug in x is equal to 0, where they're going to have our y has to be less than or equal to 10. And then when we plug in that our y is equal to 0, we are going to have a 0 less than or equal to 10 minus 2x. So we will have a 2x less than or equal to 10. We'll divide both sides by 2, say x has to be less than or equal to 5. So these are our equations. When our x is 0, our y is 10 up here. And then when our y is 0, our x is going to be 5 down here. So we can draw this line. Now, how do we maximize this? Well, we have to look at all the constraints. We can't look at this big area because it's infinity, and we can't look infinitively. Now, we're going to look at the smaller area. However, it's not touching the x constraint. Actually, this is our y constraint down here. It's not touching that. It's only touching 3 parts. So we can't do this. And for the same reason, we aren't able to use this small space down here. However, if we look in this region that I'm shading in right now, we can see that it touches the y-axis, touches the x-axis, which is the constraint for x greater than 0 and our y is greater than or equal to 0. And then it also touches the third part, which is this right here. It touches it down at the bottom here. And then also touches our second part and that's clear right here. So that is how you go about solving for this problem.